Okay, go live. Okay. Okay, we can, I think, can start now. Yeah. Okay. So, hello everyone. I'm excited to introduce our guest speaker today, Kevin Kreuzer, a Google developer expert in web technology and Angular. Kevin is not only seasoned blogger, coach, and a JavaScript enthusiast, but also a writer for Angular in the Depths, Hacker Noon, and IT Next. Today we're diving into the world of Angular signals with Kevin, who brings a wealth of expertise in this field. Let's welcome Kevin Kreuzer. Kevin, take it away.
Okay, thanks for the kind introduction. I'm very happy to be here. So yeah, I'm very happy to speak today about Angular signals, basically Angular signals, the future of Angular. I don't know if at any point you have some questions, just drop them in the chat and we can then also go through them at the end. So when I prepared this talk, I came across a quote and I want to open the talk with this quote. So basically the quote comes from Eleanor Roosevelt and the quote is, "The past is behind, learn from it. The future is ahead, prepare for it. And the present is here, live it." And I thought this is kind of cool quote to actually explore Angular signals, because Angular signals kind of try to undo some of the design decisions made in the past. They for sure will shape the future, and they are here right now, so we can use them today. So I thought we will explore the past, we will see the present, we will explore the future. So I thought it would be cool to have a time machine so that we can basically travel in time. So I used AI to build this time machine here, and I am Kevin, as already introduced. I go by the name of Nivek. I'm the creator of this time machine. You can find my next on at Kreuzer Code. I'm also a Google developer expert, and I stream on YouTube, on Twitch. I maintain multiple open source libraries and blog quite a lot. But I'm pretty excited about Angular Experts. So angularexperts.io is a website I'm building, or a platform that I'm building with a good friend of mine, Thomas Tryon. And we are basically posting blog posts, videos, products, and all kinds of stuff, Angular books. So feel free to check that out. So let's directly jump into the time machine, and we will travel back to the year of 2010. And that was the year where the iPad was released. So that was the first year the iPad came out. That gives you kind of context. For myself, I was not even programming back in that year, but I heard, or still, no, I know this because I was then also doing this, but websites were basically built like this. So we had our HTML, and then we're including jQuery and sprinkling a bit of jQuery on top here, right? In fact, most of the websites today are still built like this. And we were also using PHP. If you remember, the good old times where you had prime faces with the JSF stuff and you change the CSS property and you hit to reload like multiple, like 10 minutes or something. Yeah, not so, those times were not so cool. So we were all pretty happy when in October 2010, AngularJS came around and changed the landscape. And by the way, if you thought this will be an Angular Signals talk, it's actually an AngularJS talk. So before you drop out of the meeting, this is just a joke, right? But I still want to show you a couple of things that changed when AngularJS came. And what changed was basically we got the MVC pattern, so the model view controller. So for the first time, we kind of separate the view and the model and the controller. But this was pretty cool because it offers new possibilities on how to structure applications. But it also introduced a new challenge, like how do we synchronize the state between view and model? And the answer that we came up with that was basically change detection. And change detection in Angular is the process of automatically monitoring and updating exactly the view and the model. Yeah, this is not so important. So Angular was still using this dollar digest and so on. So that's everything that we want to take from that year. So let's travel forward to the year of 2016. That was the year where DiCaprio got his first Oscar for The Revenant, but he was not the only one that made a big appearance on stage. It was also the year where we got Angular, so Angular 2 basically. This was a complete rewrite of the AngularJS framework. So the naming is not the best. We had AngularJS and now we speak of Angular. So basically Angular 2 is just referred to as Angular. And as I said, it was a complete rewrite. So I remember ngConf where the Angular team went up on stage and was presenting this slide, like rest in peace controllers, rest in peace $scope, rest in peace JQLite, like rest in peace everything. And everybody was kind of panicking and freaking out because we have to rewrite our application, right? But the cool thing was, or we were speaking of change detection. And of course, since we have rest in peace for all those concepts, we also had new change detection or a new approach to change detection. And to fully understand what signals aim to do, we also quickly have to understand a bit of change detection. So Angular internally has a component tree, and the component tree is just a visualization of our app. So this differs from the DOM tree because it represents something different. So basically, imagine an application where you have a customer feature and a products feature. Under the products feature, we have a products list, product details, and so on. So that's basically what Angular internally knows, a component tree. That's one of the important pieces of change detection. Another important piece is Zone.js, because Zone.js monkey patches all not all JavaScript events, but around 250 JavaScript events. And you can see them here. So I listed a bunch of those. And basically, let's take a look how they play together to perform change detection. So we have our change detection tree. Now, let's say we have a change that happens in the product details. Now what is going to happen is a click happens and Zone.js patches that click event. So Zone.js kicks in and tells Angular, hey, Angular, something changed. Please go figure out what changed. But he doesn't deliver information where a change happened. So he just says, go figure out Angular. And he does it by doing appref.tick. So appref is the application ref.tick is basically the function that invokes change detection. So what Angular then does, it traverses the component tree. So it goes through the tree and dirty checks each component with the previous state against the current state. So basically a lot of checks, right? I mean, here we have a small application, but imagine a bigger application where you then also pull in Angular material or some UI libraries. In such cases, you have to perform quite some checks. And that's unnecessary work that we actually have to do. And of course, the Angular team is pretty smart and is aware of this. So what we had in some point, we had the on-push change detection strategy. Now let's see how our app is impacted by having on-push component. Let's say we still have a click on the product details component. That click happens. And now what is going to happen is basically this red dot means mark those components as dirty so that they are checked during the next change detection. Zone.js then kicks in, but now here comes the difference to the default change detection. We only check the one with the red dots. So means we can basically only check the right side of the tree, and we can completely skip the left side of the tree. And that's basically an amazing benefit because we reduce the checks by more than half. So depending on the scenario, of course, but in general, we reduce the checks by a lot. But if we think about this, it's still not fully optimal because actually what we have is, wouldn't it be cool if we would directly check for the product details? So if the change happens in the product details, we could go to product details and only check there. So currently we use this top-bottom approach. So we start from the root component and we traverse the tree to figure out what changed. And we do that in a default change detection and in on-push. But wouldn't it be cool if we could just know, well, something changed here in this component. Why not just check that? So if we would want to achieve that, let's think about how we could do that. So maybe we could extend Zone.js. So if Zone.js would deliver the concrete information about what or where a change happened, we could just run change detection for that component, right? But Zone.js actually doesn't do that. So it doesn't deliver any information. So, okay, we would need to extend Zone.js. But if we are anyway thinking about making this better, let's also revisit other downside of Zone.js, because if we just extend Zone.js, we still have some downside Zone.js brings with it. Maybe we could also take this as a chance to completely remove Zone.js, because Zone.js itself doesn't work with all the native APIs. So whenever the browser evolves and introduces some new APIs, Zone.js has to be evolved as well. And the problem there is that, for example, async await. Now, async await is working natively in the browser, and you can still use it in the Angular code, but it only worked because TypeScript then, the TypeScript target transpiles it down to promises, and therefore you can use it. But if you use async await native, then this would not work with change detection in Angular. Zone.js also has a potential for too many change detection runs because it patches a lot of events, and maybe you don't want to run it always. So sometimes you need to run stuff outside of ngZone. And if you check your package.json, you will see that Zone.js is listed as an extra dependency. So Zone.js is a standalone library which has an initial load cost. And that basically is another downside. So probably it would be cool to go zoneless. And if we could wish, or if you want to go zoneless, we probably need something like a new reactive primitive. And if we could wish for some criteria in this new reactive primitive, we would want that primitive to deliver fine-grained information about model changes. So basically, it should deliver where a change happened. It should have synchronous data access because that makes it way easier to work in templates. So also with RxJS now, it's sometimes a bit troublesome to work in templates. We have the async pipe, which delivers a synchronous value, which is null initially. But it would be cool if the primitive already has this. Glitch-free execution, we don't have time to dive too deep into this, but there's a famous problem in the RxJS world, which is referred to as the diamond dependency problem. You can then also look for that. But basically, it means if you use combination operators, you end up with intermediate states. And that's not what we want. Another cool thing would be that we have automatic dependency tracking, because now with RxJS, what you need to do is you manually need to unsubscribe always, and you need to manage your subscriptions. If you don't do that, I've been in big enterprise projects where this was leading to like huge performance issues, and they are then very hard to fix once you get to that point. Cool. So we know that we need something, or we know that we now have Angular, and we know how change detection works, how on-push works, and we know that it would be cool if we could have local change detection. So let's take all those wishes again into our time machine and travel forward to the year of 2023. In 2023, I got an invite in my calendar to discuss a RFC. So the Google team now has this, or the Angular team has this approach where they come up with an RFC. They first discuss it internally also with the GDs. Then it's released publicly that everybody can discuss with it. And then they release it usually as a development preview so that we can really hands-on try it out, give feedback, and then basically they release the main thing. And this was the RFC for Angular signals. So what is signals? It's basically the new reactive primitive for Angular. Now, as you probably know, signals were released in Angular 16, as I said, as a development preview. And then in Angular 17, they were finally released stable. For everybody that hasn't never seen this logo, that's the new Angular logo. So in Angular 17, Angular basically released so many great features. So they released defer loading, new control flow, improved SSR, signals, and so on. And they also wanted to represent this movement to modern Angular with the logo. And I think this is a pretty cool thing. So now, Signals are there. Let's move into the time machine. Let's move forward to 2024 and let's see what we can use today. So now I want to switch to a live coding demo session. Yeah, I hope you can all see my ID. And what we have here is we have a single component, a standalone component, and here we have basically the running application. We use one component which is called ng Web Console. That's an open source library, a small one that I did a couple of weeks ago. It's a small library that basically just visualizes console log statements. So if I go ahead and do console log, ng Asia, basically you will see that appear here in the browser. It's a bit easier to visualize console log than doing it in the console itself. So, okay, let's start by creating a signal. And I like to think of a signal as a box. So it's a box where I can put some values in. Imagine you have a box, a real box, and you put the shoes into that box. Okay, now you have that box. And then if you want to take out the value, so let's say we want to take out the shoes of the box, we have to call that signal. So here the Angular team was discussing a .value or get, but basically they ended up with a normal function call. Now, if we do that, we can see that we take shoes out of our box. And that's basically how you can think of a signal. It's basically a placeholder for, not a placeholder, a holder of a value. Now, as we can see, as IntelliJ or WebStorm tells us, it returns us a writable signal. So what is the difference between a signal and a writable signal? So internally, a writable signal extends a signal and adds a bunch of functions. So what it adds is a set function. So what we can do is we can say this box.set, and we set now a t-shirt into the box. Now, if you have worked a lot with RxJS and you hear signal reactive primitive, you might think that this console log would get called again. But that's not the case because signals are eager push and lazy pull, means nothing happens if you do not recall that. There's no callback provided. You have to recall basically the box or the signal. So it's like really thinking in this picture, you have a box, you put shoes in, you take the shoes out, you put a t-shirt in. If you want to take the t-shirt, you have to take it out again, right? Another function that is provided with a writable signal is, let's say this would be a number, and we want to increment that one. What we can do is we can say this box.update, and we can pass in a callback where we get the current value, and we can then increment it. So this would log 0 and 1 to the console. If you have been using signals in version 16, they also had a mutate function, and the mutate was basically the idea that if your value is a non-primitive like an array, that you basically get here access to that non-primitive and you could do v.push1, right? But the problem with this API was that this does not work with ng changes currently. So if you pass an immutable, or if you mutate just like, if you just push something into a non-primitive, but it's still the same reference, then ng changes would not run. So it's always recommended to use an immutable approach. And therefore, what you can do is use the update. Then here you use the spread operator and you pass 1 in, and you will get an array of I missed the dot. You would get an array of 0, 0.1, right? Cool. So that's basically what a writable signal is. A writable signal has one more function. So we have seen that it basically has like the signal, you can take a value out, but it also has a set and update, but it has one more, and that's as read only. And as read only returns a signal. So when would you want to use that as read only? Let's say you have a injectable, for example, which is provided in root, export class, let's call this counter service. And on here, we have a counter signal. Now, if you would inject that here, so private counter service, Copilot is so nice for live coding. You get the counter service. And now what you could do is you could say this .counter service .counter .set, and you could just set the value of 5, right? Nothing prevents you from that. But probably as a service provider, you don't want this to be set from the outside. You want this to be a counter that is incremented. So what you would do is would basically say, this is a private internal counter, something like this. And then you have a public counter, which is this internal counter as read-only. And then you would here provide an increment function, which basically increments the counter. So as you can see, this is a writable signal and this is a signal. So now, if you do that, you can no longer set it. You can just take the value, but you cannot set it. And that's the idea of this. If you have worked with RxJS, you might have seen something like this, subject, and then basically as observable, I think was the function name. It's basically the exact same pattern. Now, I want to show you things based on a Angular component. So here we are just using like a normal constructor, but not yet Angular templates. So let me quickly clean up the console logs and let's go to a counter component. Now in this counter component, we again have our web console, but we also have a count and a button. And now let's say we want to display a count here. So what we can do is we can say we have a count, which is a signal. And the signal always has initial value. So you can see that it's red because it needs an initial value. Now we can add a click handler. So we can say click. Sorry. Increment. So here we do increment counter. And we create that increment counter function, right? And here we do this count.update. And now, if we want to display this inside our template, what we can say, we can basically say count, and we have to call it. Now, in the past, we learned, or let's first see the running application. We can see that we have a counter, which is nicely incremented. In the past, we've learned that calling functions from Angular template is considered a bad practice, right? Because this calls during the change detection, basically. And with Angular signals, this is the preferred way. And it's perfectly fine to do so because the signals are also highly optimized for performance and memorized and so on. So that's the preferred way. But now, here comes the question, and I think this is important to understand, is if I would do this.count, say like this, I would still get the log of 0, right, initially. Then I have my counter, and if I click, the counter here updates, but this one stays. And why is that? Because I'm basically calling it here and here. So how come that it works in the template, but not here? And I think this is an important point to understand. So if there are questions, I think we do questions at the end, right? Or is there something at this point?
Yeah, maybe in it. And
okay. Cool. So basically, if you use signals, like they behave intuitively and they just work, as we have seen with the click handler. But there's a lot going on behind the scenes if you really think about it. So let's take this component template where we use the signal here. Where's my mouse? And then what we have our button and also our template call. So once we click our button, we can see that basically Zone.js clicks in. And Zone.js starts to invoke the change detection, as we've seen previously. It then traverses the component tree and runs change detection for each component that was marked as dirty. And that means that it basically recalls those template strings, right? So it recalls our signal. So it's essentially the same as on every click handler, you recall this count, right? And then you can see how this also nicely updates. But it's really recalled by Angular. Cool. So now what we want to do is we want to do a bit more advanced stuff. So let's say we want to display a double count. So double count is basically the double value of our counter. So what we can see, what we can do is we can create a double count variable, and this one is a computed signal. And the computed is a function that is provided by Angular, which takes in a callback. And in this callback, I can access other signals. So I can say I want to access the count signal. And now whenever the count signal value changes, our double count is computed. So now let's see. If we click, we can see that we have a normal count of 3, and we also display a double count. Another cool thing that we can do, or this basically, if you have worked with NGRX, this kind of sounds familiar with basically when you write. So you do here an update. It's kind of like you dispatch actions. And here you kind of have a selector, and this is like a derived value almost. So that sounds pretty cool. What else do we have in NGRX? What we have is an effect. And an effect allows us to do basically side effects. So we can say that something changed. So we can do a console log. So count changed 0, 1, 2, 3, 4, right? And that allows us to do side effects. Now, I quickly want to explain in depth a bit how this works behind the scenes. So let's go back here. And as I said, signals are eager push and lazy pull based reactive primitive for Angular. And the way this works behind the scenes is Angular constructs a graph. And this graph consists of reactive nodes. And if you check the Angular source code, you will see that there are 2 types of reactive nodes. There are consumer nodes, which basically represent a reactive context that depends on producers, and there are producer nodes. Those are nodes that deliver change notifications. So in simpler terms, producers produce reactivity, consumers consume reactivity. Now, we have seen those kind of types so far. So we have seen writable signals, computed signals, effect, and normal signals actually as well. And writable signals produce values, therefore they are producers. Computed signals, on the other hand, they consume other signals, therefore they are consumers, but at the same time, they also produce new values. So they can be basically seen as producers and consumers. And an effect doesn't produce a value, it just consumes values. Now, basically, those consumers and producers, they form a dependency graph. And this dependency graph is the base behind a push-pull-pull algorithm. And this push-pull-pull algorithm is very interesting because that's a very clever approach to implement signals. So let's take a look at this example. It's basically similar to the one we had. So we have a counter signal, which has an initial value of 0. Then we have a is-even computed signal, which is basically the counter modulo 2. So it returns a Boolean if the, basically it returns a number, but we will use it as a Boolean, and we will log is even or not. Because here, actually in the slide now that I go through, there's missing a equals 0 on the is even, but that's a detail. And last but not least, we update our counter. So I tried my best to visualize this, and it looks very complicated on first sight, but trust me, it's not so complicated actually. So on the left side, what we can see is the count signal. So that's basically the writable signal. Then we can see on the top right, a is even, which is the computed signal, and at the bottom, our effect. Then we also labeled them as producer, consumer, or consumer and producer. Now, the interesting thing is that each producer has a version and a value. So internally, each producer stores a version and a value. So the version is just a counter that is incremented, and the value is the actual value you start with. So we start with a writable signal of 0. Then the other interesting thing is each producer also has a list of consumers. So it stores a reference to its consumers. The consumers, on the other hand, they store a reference to the producer. So we have this two-way dependency graph. And the reference to the producer, in addition to that reference, they also store the version and the value. So we can see that somehow my mouse doesn't really work, but basically in the is even, we can see that the producer has a reference to the count signal, but it also stores the version and the value. And the same for the effect. And we will see later why this is important. Because now we have basically an algorithm in two phases. So the first thing is we do counter.update, and we update by basically using the callback where we increment the counter value on our writable signal. So now what is going to happen is that the version gets set to 2, so it's incremented. Remember here version was 1 on the count, now it's 2. Value was 0, now the value is 1, right? And then basically we have the graph and we push dirtiness across that graph. And that's everything that is happening when we do the update. So that's the eager update. But nothing else is happening. So nobody is notified, nothing. Now, at some point, you either read your signal or Angular basically calls the effect. So effects are always called by Angular. They are scheduled behind the scenes, and you are guaranteed that an effect runs at least once. So now this is the pull phase. So the effect starts and polls the consumer. Then that consumer polls the writable signal, so the count signal, and during that polling, they compare, is the version that that signal has the same that I stored for that signal? So we can see that basically the is even has stored version 1 and 0, but on the count is actually version 2 and 1. So it actually just compares the version. So he knows I have stored 1, but he is on version 2. So probably something has changed. And if he knows that something has changed, he pulls the new value. So he pulls 1, he recomputes his value, he updates his version, and the same happens then for the effect. I tried to simplify it because here there are a lot of graphics and a lot of arrows, and you see it maybe for the first time, so maybe it's complicated, but actually it's basically this. So you have an effect that polls, you have an is that polls is even, and then recursion, basically you have a recursion here where is even polls the count, and if necessary, so if the version changed, you pull the value, recompute yourself, you update the value, you update the version, and if necessary, then again you poll. And that's just like how the algorithm works behind the scenes. Cool. So the push-pull-pull algorithm guarantees lazy and glitch-free execution. Now, we were speaking about local change detection initially, right? So far, we haven't seen any of that. So let's take a look at that. So if you go on X, you might see somebody posting something like this. When using onPush and signals in Angular 17, we get local change detection. And let's take a look if that is actually true. So to visualize this, I made a small change detection demo. So I probably have to make the screen a bit smaller. And I have one component which is called change detection demo component. So I put all the components in one file so that I don't have to jump around. But basically, this is a visualization of the component tree. So we have a parent component, which has a child 1 and a child 2. Child 1, again, has a grandchild. Now, the interesting thing here is if I click here, then basically you can see the color changes, right? Color change means we run change detection. You can see that the color for child 2 does not change. And the reason for that is all the components are on push. Means, again, as we've seen in the previous slide, we mark as dirty, we mark this as dirty, we mark this as dirty, and we run change detection for all of them. If, of course, child 2 would not be on push, but just change detection strategy default, then of course we would also change the color for that one, right? Which is an unnecessary check. Cool. So now, okay, the guys on Twitter were saying Angular 17 on push local change detection. We are Angular 17, we are on push. And we have signals. So now let's take a look. We have a signal service, a counter service, sorry. Probably it's at the bottom of the file. So we have a counter service which has a counter observable and a counter which is a signal. And now inside our component, inside the grandchild component, we just use that service to increment the signal and use it inside the template. I can still show you that if you want to see that. Maybe it makes it a bit clearer. So we have something increment counter, we call counter service update, and then we consume counter service counter. Now, with local change detection, we would expect that the color only changes for this one. But as you can see, it still changes for the whole tree. So what about local change detection, right? So there's no local change detection. Okay. Then let's say we increment the signal from our parent. Let's do that. And we still consume it here. Now, the situation looks a bit different because now, look at child one. Child one never changes the color. So basically, this is local change detection. But you might say, okay, maybe that's just because we call it from parent or so. But let's see what happens if we increment the observable. If we increment the observable, then child one still changes the color. So let's go through those scenarios that we really understand those. So let's first call the observable scenario. So if you have an observable which increments something over a service and then it's consumed here with the async pipe. So what the async pipe under the hood does, it subscribes to the observable and handles the subscription, but it also calls mark for check, which marks this whole tree for check. And then we run change detection for everything, right? Now, in this scenario where we increment the signal from here, basically what is going to happen, we still have zone.js, and that means that the click is still picked up and still the whole tree is marked as dirty, right? So those scenarios still occur because if you use onPush today, basically you run change detection for the subtree if one of the input properties here changed by reference, if an event occurred in one of your child components, or if the component was marked for check. And since the event occurs here, we still run for the whole tree. Now, if we do it here, the event happens here, and the signal is consumed here. In that case, we basically mark the parent for check, but then internally Angular marks child one for traversal, and here he knows that the signal is consumed. And therefore, we get local change detection. So this can be really cool that you get that today when you use NGRX, right? With NGRX, you have something somewhere, and then basically you could really get local change detection. But so therefore, the Twitter statement is kind of correct, but also doesn't tell the full story. So if you just use a signal here, you will not have local change detection at the moment. Now, we've spoken a lot about reactivity, reactive primitive, and reactivity probably rings a bell. Like you think, okay, what about this guy? We already have reactive programming. We already have RxJS. So yeah, obviously that local change detection, but yeah, what happens to RxJS? So RxJS has some drawbacks, and it's basically they can be sync or async, which makes it harder to work in template. There's also, we wish for that's also why signals always have an initial value. So therefore they are sync. Cold observables can have unintended side effects. So if you subscribe to a cold observable multiple times, you may fire multiple HTTP requests as a side effect. As I already said, this diamond dependency problem, which we will not dive into, but it has some glitches. And therefore the question is kind of, will signals replace RxJS? And I would say no. But I think the Angular team was mentioning on a podcast that there might be a future where RxJS could become optional. And why I say no is because I think RxJS still has some advantages. So it has many operators. It's kind of like a Lodash for async. It has great error handling. And it's very powerful in dealing with network requests. So when you use something like switch map, contact map, exhaust map, all these kind of operators. And also the Angular team thinks that way, and therefore they came up with a RxJS interoperability. So that allows us to use signals and RxJS to leverage the best of both worlds. So they came up with a toObservable function and a toSignal function. The toObservable function is pretty easy. You have a signal and you use toObservable to convert that signal into an observable. Straightforward. Now, when you use the toSignal, there are two ways to use it. So since an observable can be sync or async, you can use it either like this. So you use toSignal with myStream and you say require sync true. So that would be a sync observable. And for an async observable, you just use myStream and then you pass in an initial value. Since the stream is async, you would start with initial value of loading. Now, I said that I think RxJS still is very beneficial for certain use cases. And I think one of the use cases where I would actually not know how to implement this without RxJS, and I'm not sure how other frameworks do this, to be honest, is basically a GitHub user search, kind of like a type ahead functionality. Because you have an input field and there are actually quite some requirements, because if you think about it, you probably only want to send a request if the user did not type for 200 milliseconds, right? You want to display a loading spinner when the request is made. You want to cancel outgoing requests, because what you don't want to have is basically multiple requests going out. So you also don't want to end up in that scenario, because actually you have no control over the request. So let's say you type something, you fire out one request, then you type something again. And if the first request takes longer than the second request, basically you might end up in a scenario where you display wrong data, and you want to avoid that. Also, if I come and type like pretty quick, you don't want to fire like 5 requests, right? So this is a pretty cool use case. So let's take a look at this. I prepared a GitHub user search example. Let me go to the GitHub user search component here. And what we have is a GitHub user service that will fire the backend request. And we also prepared some ng4 and so on. So we have our input field. And on input event, we call handle change with $event. Okay. So now let's start by having a input change. And of course, this will be a signal, since we now work with signal. Initial value, we start with an empty string. Now in the handle change, we say this .input change.update, or we can just do set event target value. So we set a new value inside our signal. Cool. Now we want to display GitHub users. Okay, let's use our input change. Nice. So we now have our input change, but probably we now want to come up with all these nice features, right? So how do we do that? And now I think, or what I like to think of, is walking down the street, and on the left side you have stores, and on the right side you have stores. On the left side you have signal stores, and on the right side you have RxJS stores. And at this point we say, well, we would actually need some cool features from the RxJS side. So let's go to the right side of the street and pick up from the store what we need. So what we would do is we would say, well, toObservable. And now we are in observable land. And we can say, okay, we pipe that. We use a filter if the length is 2. We use a debounce time of, 500 is a bit too much, 200. Then we say we want to tap in, and we want to say loading true. Then probably a switch map to fire off the request. Switch map we have to import. Then GitHub user service dot, how's the function called? Search users. And then probably a loading false in the end. And now we have an observable, but we want to go to the template and take advantage of the sweet local change detection. So let's cross to the left side of the street and say, well, okay, to signal. Why not? Now we are in signal land. And since it's an async observable, we start with an empty array. Of course, now we have signals, means in our for loop, we have to call that. And then basically what is going to happen is, if I go to the GitHub user search and I type something, I have a nice GitHub user search implemented, right? With even a loading spinner. I don't know if you saw that initially, but also the loading spinner displays. Now, yeah, that was backup. So cool. That is what we can use today. So let's re-enter the time machine and go forward to probably, I don't know, summer this year. And in summer, I expect to get Angular 18. And I hope that with Angular 18, we will get something that is called signal components. And what you can see today, we have standalone components. So standalone components are basically done by putting the standalone true flag on the component decorator. And we will also get a signal true flag. I guess. This is not official API. This might change. Maybe they just do signal true and say if your signal component automatically standalone, or I don't know yet. Like we all don't know yet, but I can imagine something like this. And once you use that signal true flag, you would get automatic local change detection. Another thing that basically changes when you use the signal true flag is you would only run change detection for signals in your template. So if you just use a normal variable, would not run change detection. So everything is basically signal inside here. That would basically also impact the signal component inputs. So let's say you have a component and you would get an input, you would retrieve that as a signal. Today we do at input. And this, by the way, is already available in 17.1. So in 17.1, you already get signal inputs. If you want to know more about that, I have an article on AngularExperts.io and a YouTube video about that. Feel free to check that out. But basically, you get signals as inputs here. And that's available already in 17.1. Model inputs, they are not available yet, but the idea here is you would have a checkbox, so some checkbox component, and inside there you basically have a button that toggles the checked state. And as you can see, we use their checked equals model false. And this model is basically a writable signal input. Because with signal inputs, they are read-only. But now you could consume that in a parent component with the two-way binding syntax. And that means you could then change the flag in the child component and it will reflect back up. Another thing is viewChild and viewChildren. So again, new API, you would retrieve them as signals. Instead of add viewChild, add viewChildren, you would get it like this. And the same for outputs. Outputs would also be signals. So if you have something that you want to, basically an event that you want to emit out, it would be a signal. And again, a new API. Signals also have a big impact on lifecycle hooks. So currently we have those lifecycle hooks. We have ng-on changes, ng-on init, and so on. You probably all are familiar with those. And ng-on changes would go away. You don't use that in signal-based components because an effect and the computed can be used. Since the inputs are signals, you can use effects and computed to basically calculate those values. ng-on init would stay. ng-do-check can be done with an effect. After content init, after content checked, and after view check would go away because you can use that with signals. After view init will become after next render, and ng-on destroy will stay. And I don't know yet, but I guess, or I hope that we could see that with Angular 18. And with that, basically, kind of brace yourself. Angular 3 is coming. Like, fun fact here, there was never an Angular 3. So we had Angular 2, Angular 4, 5, 6, all the way up to 17, but never a 3. And the reason for that was because they wanted to keep the package names at some point like unique. So Angular Core, Angular HTTP, all the same. And they already took the router to 4 when they decided to do this. And then basically, therefore, they had to take the other packages also to 4. Yeah, so if you want to know more about this, I wrote a small ebook about that, around 150 pages, which goes in more depth, covers some edge cases, some practical use cases. You can find that on Angular Experts IO products ebook signal. Also, if you like my theme, that's basically also available. It's a theme that I created myself. It's named Skull. Feel free to check that out because I was not so happy with the available theme. So this is my favorite theme, which I use every day. Feel free to check that out as well. And with that, thank you. It's not me that cannot write thank you. That's AI.
Yeah, we have a couple questions from the subscribers, so I will send it
Yeah.
to chat. Okay.
Okay. So the first question is, what advantages do reactive inputs offer over traditional approaches in Angular component development? So with reactive inputs, I guess you mean signal inputs. So what I want to show you is quickly, I think the easiest way to show you this is by going to the blog post that I recently published, because there it's kind of explained. So on this blog post, what you can see is an example where you, for example, an example where we have a is even component. And, or we have, this is even component takes an input, a counter, and then calculates if the value is even. And the way you can do that today is you can either use a setter and then basically calculate is even, and you display that. So you need an extra attribute. The other way you can do it is by using ng-on changes. Those are the classic ways that we can do that. But with signals and computed, we basically have a fully declarative approach. So here it's kind of if it's still imperative, right? And here is the same imperative with basically you assign the value. Kind of you do something if that happens. And here you just say you have a counter, which is a signal input, and an is even, which is the computed one. So I think it just becomes more cleaner, more declarative, and you don't need the lifecycle hooks at all. I think it makes it easier for Angular. And it standards the use case, because here you already have two approaches, either ng-on changes or a setter. And here it's just like clear how to do it. What are advantages and potential drawbacks of using signals for asynchronous data fetching compared to other methods? So actually signals will not be used for data fetching. So data fetching still returns an observable, and you basically convert it then before you go to the template to a signal. But the API from an observable, and I don't think they will change the HTTP client because that's kind of like events and signals is not really made for events. Therefore, they will still return observable in data fetching. So yeah, the HTTP client still returns an observable, the same as we've done here. You can see that basically this GitHub user service search users still returns an observable, right? And then before you go to the template, you convert it to a signal. But this is still an observable, and I think that will also stay for the foreseeable future. Either it's observable, or maybe they come up with native fetch, which returns a promise, or that I'm not sure yet, but it will not be a signal. I think they even made that on the RFC. I think they even differentiated there that event-based things like HTTP request will not be observables.
Okay, thank you very much. So, okay, so we can end our meetup. In conclusion, Today's meetup with Kevin was a fantastic exploration of the Angular signals. Kevin's expertise in the dynamic presentation provided valuable insight into the web technology. Big thanks you to Kevin for an inspiring session, and we are excited for more insightful meetups ahead.
Cool. Thanks for having me.
Okay, thank you very much. Have a nice day. Bye.
Everybody, nice evening. Bye-bye.